Let's take a second and talk about top-down estimation, which is the estimation methodology implemented in the QSM Slim suite of tools. One of the benefits of top-down estimation is that it's compatible with the information available when we have to make important cost and schedule decisions. If you think about when most cost and schedule decisions are made on software projects, it's usually very early in the product life cycle. Size and scope metrics available at this stage are fairly high level. We can usually find things like epics in an agile Scrum environment or high level requirements. And if nothing else is available, we can do t-shirt sizing based on the analogies of how this project compares with other projects we've developed in the organization. Top-down estimation embraces uncertainty and allows us to quantify probability and risk associated with stakeholder targets for cost and schedule. Moreover, it quickly allows us to generate alternatives that may satisfy stakeholder objectives. There's also an economic value of top-down estimation. Because it relies on top-down, high-level information on scope, expected staffing levels, and productivity, it can cut estimation time to hours or days. This time and cost savings is amplified if we have a modest amount of historic data. Alternatives are easy to generate and bound most stakeholder objectives. Bottoms-up planning requires much more detailed information on work breakdown structures, tasks, and resource types that are simply not available at this stage of decision-making. Estimation times can take many weeks to months to try and derive this level of information and can involve many subject matter experts whose time is better spent defining the customer solution than trying to create detailed plans when the scope is ill-defined. Any changes to the bottoms-up estimate assumptions require additional lengthy and costly rework cycles. I find that it's important to differentiate top-down estimation from detailed planning. So estimation is really about taking what is known about the scope of the customer needs and transforming that into a reasonable big picture timeline and staffing and cost baselines that meet customer expectations. Planning, on the other hand, is the process of defining the customer needs at a much lower level to support task execution, resource allocation, and to get the job done within the estimated schedule and cost bounds. They are both very complementary. When used together, they increase the probability of successfully delivering customer needs within the negotiated schedule and cost commitments. So I just want to take a minute and just look at some of the things that we've discovered over the last 45 years in terms of how software projects behave, in terms of their demand for resources as the amount of scope changes. So up here, I've got a little graph, and on the vertical dimension, I'm going to be looking at schedule, effort, and defects. And on the horizontal axis, we're looking at size and scope. And if I took a sample of data out of the QSM historical database, a fairly recent sample, and I was to do some regression fits through schedule versus size, effort versus size, and defects versus size, and was to plot those curve fits on a set of linear axes, these would be the curves that you would see. So if we look at the schedule or the time curve, we see that when we're down in the fairly small size regime, so small projects, notice that small changes or any changes in scope tend to have a fairly big impact on the schedule. In the effort and defect dimension, it's almost the opposite. Once we get into the larger systems, then small changes or any changes in scope tend to have a bigger impact on the effort, cost of the system, and how many defects we create. So that's the behavior. Now, if we think about when we're doing bottoms-up planning, we're usually working at the very detailed level. We're looking at individual tasks and how long they should take, how many people we're going to need over that timeline. And we're almost always working down in the small size regime. So our schedule estimates are always going to be down on the lower side of things. And if we do that for all the tasks that are associated with the system, and we just simply add those up, we generally will tend to shortchange ourselves in not having enough schedule. Because when you put it all together, all the scope, instead of being down here on the left side of this curve, we're actually way up to the right. It's a much bigger system when we put everything together. So that's what top-down estimation tries to do, is we try and get at that size component, the total size of the system, right off the bat. And that way we can see where are we on these curves, and then we can pick the appropriate amount of schedule and the appropriate staffing and cost numbers. And we also get a handle on how many defects we're likely to find. So this is all backed up, this behavior, in research that QSM has been doing for the last 45 years, and data that we've been collecting up along that timeline. Now, what makes QSM's top-down scope-based estimation work is a very simple equation. We call it the software production equation. And conceptually, it's pretty simple. So we've got something that we have to create from our customer, and we're going to quantify that in terms of the size and scope, okay? Early on, we're maybe looking at pretty big high-level measures. It might be the total number of epics that we've got to deliver, or we said earlier, it might be high-level requirements, or maybe we're doing analogy-based sizing. But it's basically a quantification of what we have to deliver that will satisfy the customer needs. And that's going to be equal to how much time it's going to take and how we're going to apply resources over that schedule. So that's the time and the effort component. And we're going to have to operate at some level of productivity. And that level of productivity is going to encompass multiple things, like how efficient we are, how well we know the application, what tools and methods we're using, complexity of this particular system, and maybe how it interfaces with external systems. So all of that stuff that affects our productivity is built into that productivity term, and later we'll call it a productivity index within the QSM methodology. The nice thing about this is we can rearrange this equation fairly quickly. So if I needed to figure out what is my productivity with my team and in my environment, we just rearrange this equation where we look at past projects and we see what did we deliver, in terms of the functionality for this project? How long did it take? How did we staff it over that timeline, and what was the effort that we expended on that project? And then we can calculate this productivity empirically for our group, our organization, or different organizations within the company. So it's easy to sort of look at and manipulate this equation depending on what we're trying to do. You'll also notice that we've got these little exponents next to the time and the effort. And what that's getting at is this notion of incompressibility of time. So if we try and accelerate the schedule by using a large team of people, you get diminishing returns on the amount of schedule compression that you get. But likewise, if you move in the other direction, if we can afford to take a little bit more time and a smaller team, we can significantly reduce the effort and the cost of the system. And again, those are empirically derived, with over 45 years worth of data. So on the next slide, what we've done is we've sort of rearranged that software equation into its estimation form. So if you look on the right-hand side, you'll see the inputs on the left side of the equation are functionality, or size and scope, and productivity or efficiency. So that's what we feed in. And then the software equation will estimate the amount of effort and time. And it just doesn't estimate one effort and time. It allows us to explore a number of alternatives and make changes. And on the left-hand side, what I've done is try to lay out some of the situations you're almost certainly going to encounter, when it comes to estimation. So the first one is we've got a fixed budget. So I've got a certain amount of money the customer is allocating. We're not going to get any more. So if I look at this equation, notice that I've drawn a little box around the effort term. So that's the indication that's locked down. And then we're looking at the other terms, and you'll notice I've got a little padlock that's next to this efficiency or productivity index term. And what that's saying is that parameter is fixed in the short term. We're not going to be able to do anything, tomorrow to drastically increase our productivity. That happens through targeted long-term, process improvements and investments in order to make our efficiency go up over time. You'll notice the other two terms, functionality and time, have little arrows next to them. And that's saying those are the parameters that we can adjust to try and make sure that we can fit within that fixed budget or fixed amount of effort that's available to us. So I've got a little up arrow next to the time, which is saying we could take more time and exploit that trade-off relationship and use a smaller team to bring the cost down. Or I could reduce the functionality in a similar way. Less scope will obviously bring our effort and our time down. Or it might be a combination of both of those things. Take a little bit more time, maybe prioritize the functionality and put low priority stuff in a second release. But those are the levers that are available to us to figure out a solution in that fixed budget scenario. The next one is a fixed duration. So we just move that box over to the time term. And again, we can see a couple things that we can do is exploit that trade-off where maybe we use a bigger team to try and get some schedule compression to meet that time commitment, or we can also reduce the functionality to reduce our cost. If we're looking at a fixed budget and duration, so both of those things are fixed, then the only thing available to us is we've got to figure out what's the right amount of scope that fits within that time and effort box. Having said that, you still have a lot of alternatives to look at to try and optimize on what is most important to your stakeholder, where maybe I use a smaller team to optimize on cost, or maybe I use a little more team, or a larger team to try and optimize on schedule. So there's a fairly good amount of horse trade that we can do even within the boundaries that we have on the schedule and the effort. And then if scope is what's fixed, so we've defined what our minimum viable product is, and the customer won't accept anything less than that, then the only thing we can really do, again, is negotiate a reasonable amount of time and a reasonable staffing and effort to get that job done. So the nice thing here is this simple little equation lets us explore a number of different alternatives based on the situations that we're likely to find ourselves in the future.